When most people imagine the race to build humanoid robots, they think of Tesla's Optimus. But the first humanoid to enter a paid, multi-year deployment in a working warehouse was not built by Tesla. It was Digit, a strange, bird-legged machine developed by Agility Robotics. And while the internet was watching robots dance, Digit was doing something far less exciting, moving plastic containers from one machine to another. That boring task may tell us more about the future of robotics than any viral demonstration ever could. Because the winner of the humanoid race will not be the robot that looks most human. It will be the first one that pays for itself. A factory does not care if a robot can dance, run, or perform a carefully rehearsed demonstration. It cares about uptime, safety, accuracy, maintenance, integration, and cost. A useful robot must recognize objects that are never positioned exactly the same way. It must work around people without injuring them. It must recover from mistakes, recharge itself, and repeat the same task thousands of times without quietly requiring a human operator behind the scenes. That creates a very different competition from the one shown in promotional videos. There is the race for intelligence, the race for physical capability, the race for manufacturing scale, and, most importantly, the race for real customers. Right now, 6 companies represent 6 very different strategies. Agility Robotics chose a narrow and practical starting point. In late 2023, logistics company GXO began testing Digit at a Spanx warehouse in Georgia. Its assignment was simple. Take containers from autonomous mobile robots and place them onto a conveyor. The task was repetitive, physically tiring, and already part of an existing automated workflow. Digit did not need to become a universal household assistant. It only needed to become one reliable link in a logistics chain. In 2024, the pilot became a multi-year robots-as-a-service agreement. Agility described it as the first formal commercial deployment of humanoid robots. The company later said that Digit had moved more than 100,000 containers in live operations. Commercial agreements with Mercado Libre and Toyota Motor Manufacturing Canada followed. Not every number has been independently audited, and the jobs remain narrow. But Agility has crossed an important line. Customers are no longer only experimenting with Digit. They are signing agreements to use it. Agility may not have built the most human-looking robot. It may have built the first humanoid with a credible business model. Figure AI is taking a more ambitious approach. At BMW's plant in Spartanburg, Figure 02 spent 10 months supporting production of more than 30,000 BMW X3 vehicles. BMW says the robot inserted sheet metal parts for welding, precise, repetitive work performed under real production conditions. That matters because it came from BMW, not only from the robot manufacturer. Figure 03 is now being introduced to a more difficult logistics task. Components arrive loosely arranged in large containers. The robot must identify them, pick them up, sort them into the correct sequence, and handle a heavy cart. Unlike a fixed industrial arm, the robot must adapt when objects shift, rotate, or partially block one another. Figure says its Helix system coordinates vision, hands, arms, torso, and feet to make continuous corrections. But there is an important distinction. Figure 02 has a meaningful production record. Figure 03's new BMW workflow was presented in 2026 as the next project and an early demonstration. It has not yet accumulated the same operating history. Figure may currently have the strongest evidence that a general-purpose humanoid can perform increasingly complex factory work. Agility, however, still has the clearer evidence of paid commercial operations. One may be leading the intelligence race. The other may be leading the business race. Apptronik's Apollo reveals another side of the industry, the enormous amount of human work required to make a robot appear intelligent. Mercedes-Benz has tested Apollo for internal logistics and quality inspection tasks. The automaker also invested a low double-digit million euro amount in Apptronik. But Mercedes explains that its employees transferred production knowledge to Apollo through teleoperation and augmented reality. In other words, humans demonstrated the work while the robot collected data. In 2026, Apptronik described fleets of Apollo 2 robots collecting training data at its robot park facilities and customer sites. The company openly states that this combines teleoperation with autonomous execution. The goal is to train future commercial systems with Google DeepMind's robotics models. This does not make Apollo fake. It reveals how embodied intelligence is actually built. Behind every apparently autonomous robot may be thousands of human demonstrations, corrections, simulations, and failed attempts. Apptronik is well-funded and supported by major industrial partners. But its own material shows that Apollo 2 is still primarily building the data and reliability needed for a future commercial fleet. Then there is Atlas. Boston Dynamics has decades of robotics experience, and the electric Atlas is technically formidable. The company lists a maximum short-duration load of 50 kilograms, a sustained capacity of 30 kilograms, 4 hours of battery life, and autonomous battery replacement. Hyundai plans to deploy Atlas at its Georgia factory by 2028, beginning with parts sequencing. Component assembly is planned for 2030. That timeline is revealing. Atlas may be one of the strongest and most advanced industrial humanoids ever built, but large-scale customer value is still a future objective. Its current status is closer to an enterprise product entering field validation than a proven commercial workforce. Boston Dynamics may be arriving later because it is trying to solve a harder problem, a powerful, serviceable machine designed to operate continuously in demanding industrial environments. If it succeeds, Atlas could rapidly change the ranking. But today, its economic case remains largely unproven. Tesla has something every competitor wants: manufacturing experience, access to AI infrastructure, capital, and enormous public attention. Its official AI page describes Optimus as a general-purpose autonomous robot intended for unsafe, repetitive, or boring work. But that page provides no comparable customer deployment, operating hour, productivity, or commercial contract data. This does not prove that Optimus is behind internally. It means the public evidence is not yet strong enough to rank Tesla alongside robots already documented at customer sites. Tesla may eventually have the greatest ability to manufacture humanoids at scale, but scale only matters after the machine can deliver reliable value. Until then, Optimus remains the most famous participant, not the most commercially proven one. China's Unitree is attacking a different constraint: price. The G1 starts at $13,500, dramatically below the price usually associated with advanced humanoid systems. But its base specifications also show the trade-off. Battery life is about 2 hours, and the standard arm payload is approximately 2 kilograms. Unitree itself warns buyers that the humanoid industry remains at an early stage and that some displayed capabilities are still being developed. The G1 is better understood as an accessible research and development platform than a proven industrial employee. Still, price changes markets. A cheaper platform allows more universities, developers, and companies to experiment. Unitree may not lead commercial factory deployment today, but it could accelerate the ecosystem faster than its more expensive competitors expect. So who is winning? If the measurement is paid commercial operation, agility has the strongest case. If the measurement is increasingly complex work under real automotive production conditions, Figure may be ahead. If the measurement is industrial strength and long-term engineering potential, Atlas is the contender to watch. Apptronik is building the data engine. Unitree is attacking price. Tesla is preparing for scale, but has not published enough comparable evidence. There is no single leader because the industry has not yet solved the complete equation. Capability is not enough. A robot must also be safe, reliable, serviceable, autonomous, manufacturable, and economically useful. And the first mass-market humanoids probably will not enter our lives as science fiction companions. They will arrive quietly, carrying a container from one conveyor to another, sorting parts beside an assembly line, and performing the tasks most people never notice. The company that makes those boring jobs profitable may define the next era of labor.